Now today we have to perform the practical, which is coordinate stakeout, remote distance and remote elevation. What is coordinate stakeout? Coordinate stakeout means we have to find out the missing details. That is, we have to find out the missing stations. Suppose today we have done the survey and the extreme event like heavy rainfall occurs. Then tomorrow we are unable to identify that particular stations. So in this case we have to perform the coordinate stakeout practical. Okay, so we have to find out the missing details. So we will see how to perform this practical. First of all, we have to set the tripod stand and we have to make this plate parallel to ground surface by moving any one leg. We have to unlock this attachment and we have to move it in vertical upward and downward direction in such way that this plate must be parallel to the ground surface. Now you can see here the plate is parallel to the ground surface. So temporary leveling we have done here. Now what we have to do after that, we have to fix this total station to this tripod stand by this clamping screw rotating in clockwise manner. Now already we have seen the previous video which was related to the topographical survey, that is area measurement. Now what we have to do, we have to start the instrument. You can see here by pressing green key. The instrument is started. So now what we have to do, you can see here the display is appeared. Now what we have to do, we have to first do the centering and after that we have to complete the leveling process. Now for centering, you can see here the laser, it is appeared on my hand. We have to shift this laser on the ground surface. And now we have to make the marking. You can see here. So here you can see the laser is appeared on this tile. The cross mark I have done here. So this is your instrument station. Now we have to complete the leveling process. So you can see here. Now we have to do the leveling process. In this you can see in this window there are 3 level tubes. One is longitudinal level tube, circular level tube and transverse level tube. Now we have to make this bubble completely at the center by this 3-foot screw in such way that I will mention one thumb rule here. This bubble, circular bubble, is towards left side, so we have to move or rotate the opposite foot screw in clockwise or anti-clockwise manner in such way that this bubble must come at the center. So I am rotating the opposite foot screw. Now you can see the bubble, it is moved towards the right direction, so I will rotate the opposite foot screw in such way that this bubble will come completely at the center. Now you can see that the circular bubble, longitudinal bubble and transverse bubble is completely at the center. So I will click on disable compensator and I will accept. So the leveling process is now completed. Okay. Now what we have to do, first we have to go in the file option, open job. Now in which job we will do this particular operation. So the previous file was SESA 1. So I will open this particular file, SESA 1. Now I have entered in this particular file. So that is mean that the whichever object I will bisect, that will store in this SESA 1 file. Now what, after entering in that particular file, we have to click on the measure topo option And in this measure topo, you can see here the map option is there. Click on the map. So previously how many points we have bisected? This one was instrument station, second was north direction, third was the object point, fourth was object point, and fifth was object point. Now I have to stake out this third point. So I will long press on this third point and I will click on stake out option. Okay, now you can see here it is showing that the point 3 is towards right, that is 20 degree 33 minute and 5 seconds. So now what we have to do, first we have to bisect the prism in such way that it will show that at what distance and at what angle we have to shift from one location to other location. So the prism 1 will go forward. Now you can see that the prism 1 have to shift towards right, probably that is 3.93 meter, and in backward direction that is 3.13 meter. So go behind 3.13 meter and move towards right, that is 3 meter. Okay, go back. Now you can see that the location, the point is approximately at the same point which we have conducted the survey yesterday. Okay, now what we have to do, we have relocated the third point with reference to yesterday's point. So today's we have find. Now you can see this, this is the actual position of the point number 3. So the stakeout for point 3 is now completed. Now the second special function which is available in total station is remote distance. Now we have to work in the same file, that is CSA file. Now in CSA file we have to first bisect the object number 5. In this we have to select this option. You can see here we have to select remote object option. Now after selecting this remote object option, we have to bisect that point number 5. After bisecting point number 5 perfectly, we have to press on the measure option. Now the features are saved in this particular point number 5, that is horizontal angle, vertical angle, slope distance. So I will press or click on the store option. Okay. So to select the next point, that is point number 6. After selecting point number 6, what we have to do? We have to bisect that 6 point correctly. After bisecting point number 6, you can see that the horizontal distance between previous point, that is point number 5, and point number 6, that is 4.216 meter, and the difference between elevation between that 2 points is 1.498 meter. So this object height, this is nothing but your remote elevation, and this object width, that is nothing but your remote distance, that is 4.216 meter. Now in this practical, what we have studied the special functions available in the total station. First is coordinate stakeout, remote distance and remote elevation. Now in third part, what we will see, how to transfer or how to import the data from this instrument in the pen drive, and how we have to convert it into CSV file, and after converting it into CSV file, we have to shift that data in the AutoCAD, and we have to measure the topographical area by using AutoCAD. Thank you for watching. Thank you.